So now we have got Shravya. Uh, so,
Yeah. Good morning. Good afternoon, everyone. So I'm here. Let me.
so Shravya is going to speak on the guardrails that work,
Yes.
engineering safe generative AI end to end. And Shravya is a senior technical manager at HCL Tech, and she is a technology enthusiast and an active contributor to technical communities. She is speaking. She regularly speaks on practical Gen AI adoption, trustworthy AI system design. So over to you, Shravya.
Yeah. Hey, everyone. This is Shravya. Thanks, Suresh, for all the introduction. So I'd like to straight away bring up to the topic on the responsible AI. So this agenda already shows what are the topics I'm going to cover today. Like on the first, I'll give a quick introduction on what I'm going to say. So as we already know, the generative models are moving from the research environments into the real world applications, right? Where the trust, safety, and accountability are becoming the major engineering requirements rather than the actual theoretical concepts. So which also include the main real risk also includes such as the hallucinations, bias in the generated outputs, and the potential data leakage and misuse through the prompts or prompt injection. So today I'm going to talk about how we are going to translate the RAI frameworks into the practical engineering practices, and also how to evaluate AI system reliability. And coming to the architecture, right? So at the top of the architecture are the users or the client applications which interacts with the system. This could be enterprise copilots or knowledge assistants, or also even the domain-specific AI applications. Even before the user prompt reaches the AI model, it passes through the input guardrails, and there is an input guardrails, and which these guardrails perform the checks such as the prompt filtering, prompt injection detection, and also the PI protection. This will prevent the malicious inputs or the sensitive data exposure. The request then enters the GenAI application layer, which is also nothing but an orchestration layer. This layer coordinates the workflow, manages the agents, and also decides how the request should be processed. And from here, the system will typically interact with the two key components. One is the retrieval layer, which retrieves the information from the sources like the vector databases or the knowledge repositories. And the second is the LLM model, which generates the response based on the prompt and the retrieved context. So once the model produces an output, the responses passes through the output guardrails, and finally the response is delivered to the users. Across the entire architecture, there are the responsible AI controls, which includes the evaluation pipelines, bias and fairness analysis, and also the hallucination detection. These controls ensure that the AI system remains reliable and trustworthy throughout its life cycle. And coming to right, why responsible AI matters for Gen AI. So generative AI is rapidly moving from the research experiments into the real world production systems. So which means this brings the tremendous opportunities for, let's say, the productivity or innovation. It also introduces the important risk. Generative AI systems here sometimes produce the incorrect information and also generate the biased outputs or unintentionally expose the confidential or sensitive data. To safely scale generative AI in the real world applications, organizations must design systems that include the safeguards, monitoring, and validation mechanisms where it will ensure the technology should remain reliable and trustworthy. Ultimately, I would say responsible AI is about enabling the trustworthy deployments of the generative AI systems at scale. And let's talk about the risk in generative AI. So generative AI is rapidly, so when especially deploying the generative AI systems in the real world environments, right, there are a lot of key risks, especially one engineer must always should account for. One, the top of that is hallucination. This is where the model produces the answers, which sounds like a confident, but those are actually not correct. Let's say when you ask the same question to the chat GPT, it always never receives the same answer. You will see the different answers. That's where the another problematic domain, especially like the healthcare or the enterprise knowledge systems, we will see. And another major concern is bias. This is where the system may generate the outputs that are unfair or unequal due to the patterns. Over time, we may also see model drift where the system's performance gradually degrades as data usage patterns or the environmental changes. Because of all this risk, the responsible AI cannot rely only on improving the model itself. Instead, we need a system level controls and also the safeguards around the model. This is mainly to ensure the reliability and safety in the production environments. And when we talk about the frameworks of the engineering, many have like these frameworks, especially define right what RAA should achieve. Engineers often struggle, especially how to translate these principles into the actual system design. The key idea here is RAA must move from high-level frameworks to concrete engineering architecture that operate in the real systems. Let's talk about the guardrails. There are the first category I'd like to talk about is input guardrails. These analyze the prompts even before they reach the model. For example, a prompt filtering, which will block the harmful or unsafe the inputs, while prompt injection detection helps prevent attempts to manipulate the model's behavior. And next, come to the output guardrails. This actually validates the responses generated by the module. And another layer is retrieval guardrails. These, particularly in systems using RAG, these ensure responses are grounded in the trusted sources and also verifies the data pipelines. Finally, there is a policy guardrails. This actually enforce the rule-based safety constraints, which is aligned with the business or the regulatory requirements. And another important design principle is the human in the loop design. There are several common implementation patterns. Let's say the system may require the human approval for sensitive outputs or the route responses through the expert review pipelines. Some systems also use the confidence-based escalation where the outputs with a lower confidence automatically trigger the human review. A simple workflow looks like a user submits a query, the AI generates a response, a human validates the output if needed, then the final response will be delivered. This approach usually helps ensure that AI systems are safe, reliable, and also aligned with the human judgment. And evaluating and monitoring AI. The responsible AI is not just one-time thing. It's an ongoing process. We should always evaluate. Let's say that we should put some hallucination benchmarks and also prompt testing and also model drift detection and safety incident logging. All this always RAA requires the continuous measurement. So in this topic, I would say the RAA is not just a parameter. It's a more of a beyond the policy. Every system, whatever we are building, we should always adhere with the guardrails, human oversight, continuous evaluation, and also the production monitoring. Thank you.
Oh, thank you very much, Shravya. This is really insightful and a lot of inputs for the attendees.